Okay, double check the microphone's on. Awesome. Okay. Sorry I can't be with you guys today, and the long-term sub, the one that I have that's going to be with you for March, she's not able to come in today, so you won't see her till the following week. So you get to watch me on a video. So today we're going over more triangle proofs, and there's some new things in the toolbox that I want us to look at. So I want you to get out your yellow papers, okay? And then on your yellow papers, we are going to go over what a midpoint is, an angle bisector, and triangle mid-segment theorem, because we're going to be using those a lot today. Okay, so if you find midpoint is on the front page of the toolbox, and what a midpoint is it's literally a point in the middle of a line segment. So if you have a line segment, you got the end here at A and a line here at B. Midpoint is literally the point right in the middle. So if it's right in the middle, what about line segment AM and line segment MB? What do you think about those two? Well, if M is right in the middle, they're going to be the exact same length, okay? So midpoints cut our line segment exactly in half, okay? Next one is an angle bisector. So angle bisector is just underneath midpoint. Now, if we remember what bisector means, remember bisectors cut things exactly in half. So if I have an angle and I have a bisector, it's going to cut my angle exactly in half. So if I had an angle here, say this angle was 50 degrees, my bisector is going to come and cut it in half. So what are my two new little angles? Well, they're going to be 25 degrees because it cut it exactly in half. So you need to remember bisector cuts it in two equal parts, okay? Last one, triangle mid-segment theorem. So that one, you're going to have to flip the page over. And it's the very, very, very last thing. So there's a couple things about it. So if we read the toolbox, it says the segment joining the midpoints, so the middle sections, of two sides of a triangle. Okay, so let's start with that. So let me erase this so I have room here. So what it means is if I have a triangle, okay, let's label this triangle A, B, C. It says the segment joining the midpoints of two sides. So here's a midpoint, and here's a midpoint. Joins them like that, just like that, okay? So I'll call this D, call this E, okay? So the middle point of one side, so AB, and the middle point of AC, okay? Connect those together. And what happens when I connect those together? Well, if we read, it says those lines are parallel. So it tells me that DE is parallel to this one right here, to BC, to line segment BC. That's what it tells me, okay? So it tells me those two lines are parallel, and it also tells me that line segment DE is half the size of BC, okay? So that's what it tells me. It tells me this line right here is half as big as this line, and they're parallel. So we're going to get some more practice using these three things today, just so that we can try to remember them, because the reason I'm going over them is they are going to be on your proofs, okay? So, and we're going to need them in our proofs. So the first point is just midpoint practice. So find the missing side length on each line segment that has the midpoint B. So this tells me I need to find what BC equals. So we need to find what line segment BC equals when AC equals 10. So AC is all the way here. Now, what does a midpoint do again? Midpoints cut it directly in half. So if this full length is 10, how long is BC? Well, it's going to be half as much. So what's half of 10? 5. Okay? So line segment BC is 5. So I want the sub, if you could pause it right here and give them a chance to do questions 2, 3, and 4. They can work on it for a few minutes, and then once most of them are done, you can press play and it'll have me go over those 3 questions just to make sure you have it right. So press pause now. Okay, so coming back, the next one, question 2, says find the length of AB. So we want to know what this length of AB is when BC is 7. Okay, well, remember that's our midpoint, and the midpoint cuts it in half. So these are going to be congruent. So AB is equal to 7. It's going to be exactly the same. Okay, going over here, find the length of AB when AC is 20. Well, again, AC is the full length. We want half of that. So AB is equal to 10. Find the length of AC when AB is 9. Okay, well, if AB is 9, it's half as much. So 9 times 2 equals 18. So AC, line segment AC equals 18. So that's what midpoints do, is they cut things in half. Okay, now let's go triangle mid-segment theorem practice. So if we remember, there are 2 things that we learned from triangle mid-segment theorem. Let's go back up here for a second. We learned one, that we get parallel lines. Okay, the other one is that the smaller line is half as big as the bigger line. So this question right here asks me to find parallel lines. So it says that we have line XY. What is XY parallel to? Well, these are midpoints, so it's parallel to line segment PM. Okay? So we're using the triangle mid-segment theorem. So again, I'm going to have you pause it. Then I'll go over the next 3 just to make sure we have them right. So give you a chance to work on them first. Okay, so looking over here, we have line NP, and it's going to be parallel to BA. So line segment BA, okay? Now let's go over here. MP is right here, and it's going to be parallel to RQ because of the mid-segment theorem. So we're going to be using these on our proof, so we need to learn to identify them. So next one, NP is going to be parallel to VU. Line segment VU. Okay, now we're going to get even more mid-segment theorem practice. We need to find the missing side length that's indicated. So it wants us to find what XZ is. Well, remember, the midpoints create a line that's half as big. So 2 times 2 equals 4, right? We got to times it by 2 so we can get what XZ equals, which is 4. So again, I'm going to pause it and have you work on these, and then unpause it and we'll go over them. Okay, question 2. So we know right here that QP is 10, and we want to find HJ. So remember, we need to times it by 2 so we can get 20. So line segment HJ equals 20. Okay, we know this is 11, so we got to times it by 2. So we get 22, so LN, line segment LN is 22. This one's 5, we want to times it by 2. So DF equals 10. Okay, so those are the 2 pieces of the mid-segment theorem that we're going to be using, and we're going to be using them on proofs that are going to be on your test. So let's pull out your homework. There's a couple of these we're going to do together. So I'm going to have you do questions 1, 2, 3, and 4. I know you can do those yourselves. Let's look. We are going to do question 5. And then I'm going to have you do question 6 on your own. So let's look at question 5. So it says, given ABCD is a rhombus. So that rhombus is this picture right here, ABCD, and it says all 4 sides are congruent. We're going to use that, okay? So remember, anything it gives us, it's valuable information. So ABCD is a rhombus. We need to write that, right? You get points for writing what's given and what we're trying to prove. So then what are we trying to prove? We're trying to prove that angle CBD is congruent to angle ABD. So this angle right here is congruent to this one. That's what we're trying to prove, that those 2 green ones are the same. We don't know that yet. We're trying to prove that. Well, again, when we're trying to prove things are congruent and we have triangles, there's a pretty good chance we're going to be needing to prove that the triangles are congruent. Okay, so this one gives us a hint. It says side length AD is congruent to CD. Well, how do we know that? Well, what's it say in the given? It says all 4 sides are congruent. That's the definition of a rhombus. So we know that because the definition of a rhombus. Oops. Okay, so if all 4 sides are congruent, are these sides going to also be congruent to each other? I'll just do that so that we know I'm talking about those 2. Yeah, we know they're congruent. Everything's congruent. So we know that side length AB is also going to be congruent to CB because of the definition of a rhombus. Okay. So remember, we're trying to prove the triangles are congruent. Is there anything else that's congruent on these triangles? Well, we look in the middle. They share that middle line. So is that going to be congruent? Yeah, remember our reflexive property? It says that BD is congruent to itself. So both triangles use it because of the reflexive property. Well, now we have 3 sides that are congruent. So are the triangles congruent? Yes. And why are they congruent? Because of side, side, side. And if our triangles are congruent, are everything else congruent? Yeah. Because of the corresponding parts of congruent triangles are congruent. Okay, so that's us going over question 5. Now, the next one that we're going to go over is question 7. So we're going to go over question 7. Okay. So, because this is a big chunk of information right here, this is everything that we're given. Let's look at this for a second. So we know Y, that's the one right here, is the midpoint, key midpoint. Let's remember what midpoint means. Between BC. We also know Z is the midpoint between AC. We know AZ equals 3. We know BC equals 7. And the perimeter, so that's everything, right? The whole thing equals 21. Okay. So, what are we trying to prove? We're trying to prove that YZ, so this one right here, is 4. That's our goal right here. Okay. So, because this is a big chunk of information, We're just saying everything to the left is given to us, okay? We know all of that's given to us. So this proof is already kind of giving us information. Let's look right here. So it's talking about line segment, and I feel like we should put these on here so we know we're talking about line segments, because that's how we represent them, right? So it's saying right here that AC, so where's AC? AC is equal to 2 times AZ. Why can we say that? Why can we say this big blue line is twice as big as this red one, AZ? Well, because the definition of a midpoint, right? Z cuts it perfectly in half, so we know that AC is going to be twice as big. So that's the definition of a midpoint. Okay, so notice going from this step to this step, we just substituted in 3 for AZ because that's its measurement. Okay, then we multiplied those together, so just put multiplication. So because 2 times 3 is 6, we just did that with multiplication. We know that this whole length right here, AC, is 6. Okay, that's a good start. Okay. Now, let's look at what this next one says. It says AB, so that's right here, AB plus BC plus AC equals 21. Okay. Oh, and I messed up there. BC is 7. So this is 7. The whole thing's 7. Okay, there we go. So we know that all of that equals 21 because that's the perimeter, right? To find the perimeter, you just add up all the sides of the triangle. Well, what length is BC? BC is 7. That's what it says right here. BC is 7. So we can just replace BC with 7. And we just found that AC equals 6. So we can replace that because of substitution. And the reason we could do AB plus BC plus AC equals 21 is just the definition of perimeter, right? Perimeter. Okay. So, how do I get these to get rid of these so I can have line segment AB all to itself? Well, we're going to have to subtract them, right? If I subtract both of those to both sides, if I subtract 7 to one side, I have to subtract it to the other, subtract 6 to one side, subtract it to the other, I'm going to get AB equals 8 because of subtraction. Okay, so now we know right here, this side length right here is 8. Okay. Well, how are this green line and this black line connected? Well, what do we know about them? We just did so much stuff. We know they're parallel, and we know that that green line is supposed to be half as big as that black line, right? Because of the triangle mid-segment theorem, right? So that's what this says right here. This is the triangle mid-segment theorem. It says that our line YZ is going to be half the size of AB. So triangle mid-segment. Okay, so now we already know what AB is. We know it's 8, so we can substitute that in. And then we can just do multiplication. Right? 1/2 times 8 is 4. And that is how we get this proof. And I know it's really long. I tried to do the harder one with you guys. I tried to do question 7. So read through it, okay? read through what we did and try to make sense of what we just did, okay, and how it makes sense, because it was a lot at once. And then I want you guys to pause this because I want you to do your homework. The rest of these questions are for homework, okay? But at the end of class, I want to go over question 8. So I'll have the sub pause this video, let you guys work on this, and then in the last 10 minutes, I'll have press play again, and we will go through question 8 because there's a pretty good chance you'll see question 8 on your test, okay? So I want you to try it first, though, so that it makes more sense when we try to go over it. Okay, so if you're coming back, that means you've tried question 8. Okay, so let's see what we're given. So X, Y, and Z are midpoints. Hence midpoint, we got to remember what that means. That's key. So X, Y, and Z are midpoints of the triangle ABC. Okay, then R, S, and T are also midpoints of the smaller triangle, AXZ. And we know that YC, so this side right here, is 20. Okay, so we know Y is a midpoint, and we know those side lengths. So again, because this is a lot, I'm just going to put an arrow there, showing that that's what needs to go there because it's given. And what are we trying to prove? We're trying to prove, and I'll put it in green, that RS is 10. That's our goal. So we're trying to prove that line segment RS equals 10. So let's go through this. What do we know? Let's start with what we're given. We're given stuff down here. What do we know about mid-segments and everything? Well, what length is BC going to be? Well, BC is going to be twice as big as YC. So we can say line segment BC equals 2 times line segment YC, right? By definition of a midpoint. That's what we know midpoints are. Okay, so now we know that. Can we actually find the measurement of BC? Yeah, we can, because we know YC. So we know BC equals 2 times 20 by substitution. And then BC equals 40 because of multiplication. Okay, awesome. So now we know this whole length right here is 40. Well, can we use that length to find something else? Do we know how that relates to anything else? Well, remember our midpoint segment theorem, our mid-segment theorem? How do the blue and yellow lines connect? How do they relate? They're parallel, and the yellow line is half as much as 40. So we know that line segment XZ is half as much as line segment BC, okay, because of the triangle mid-segment theorem. Okay, so let's find what XZ is because we know what BC is. We know it's 40, so let's substitute that in. So substitution. Okay, so let's do some multiplication and get 20. So that's how much line segment XZ is. Okay. Well, how do lines, the yellow line and the green line connect? Well, again, because of the triangle mid-segment theorem, we know RS, the green one, is going to be half as much as XZ. We're just going up because of triangle mid-segment theorem. Okay, so let's do some substitution. And because of, or not 10, it's 20. And because of multiplication, so substitution here, and because of multiplication, we know that line segment RS equals 10. So like I said, there's a pretty good chance that that one's going to be on your proof. And hint, 6 might be a really good one for you to do your homework of, okay? And turn that in so we can grade it. Okay, so if you have any questions, you can always ask the long-term sub when she's in. She'll be there tomorrow, Friday, and then every day until spring break. So good luck with everything.